Hello students, how are you? Okay, let's start the chapter Wave Optics. What is wave optics? The phenomenon like interference, diffraction, and polarization establishes the wave nature of light. However, the phenomenon like black body radiation and photoelectric effect establishes the particle nature of light. De Broglie suggested that light has a dual nature, that is, it can behave as particles as well as waves. Now the wavefront. What is wavefront? A wavefront is defined as the continuous locus of all such particles of the medium which are vibrating in the same phase at any instant. In case of waves traveling in all directions from a point source, the wavefronts are spherical in shape. When the source of light is linear in shape, the wavefronts are cylindrical. At very large distances from the source, a, a portion of spherical or cylindrical wavefront is plane wavefront. I am repeating once again. A wavefront is defined as the continuous locus of all such particles of the medium which are vibrating in the same phase at any instant. In case of waves traveling in all directions from a point source, the wavefronts are spherical in shape. When the source of light is linear in shape, the wavefronts are cylindrical. At very large distances from the source, a portion of cylindrical or spherical wavefront is plane wavefront. Now, what is ray? An arrow drawn perpendicular to a wavefront in direction of propagation of a wave is called a ray. An arrow drawn perpendicular to a wavefront in the direction of propagation of a wave is called a ray. Two general principles are valid for rays and wavefronts. First is rays are normal to wavefronts. Second is the time taken to travel from one wavefront to another is same along any ray. Now, Huygens principle of secondary wavelets. Huygens principle is the basis of the wave theory of light. It tells how wavefront propagates through a medium. It is based on the following assumptions. First is each point on a wavefront acts as a source of new disturbance called secondary waves of wavelets. Second is secondary wavelets spread out in all directions with the speed of light in the given medium. Third is the wavefront at any later time is given by the forward envelope of the secondary wavelets at that time. Effect on frequency, wavelength, and speed during refraction. Effect on frequency, wavelength, and speed during refraction. When a light wave travels from one medium to another medium, its frequency remains unchanged, but both its wavelength and speed gets changed depending on the refractive index of the reflecting medium. Interference of light waves. Now I am going to tell you interference of light waves. When light waves from two coherent sources traveling in the same direction superpose each other. When light waves from two coherent sources traveling in the same direction superpose each other, the intensity in the region of superposition gets redistributed, becoming maximum at some points and minimum at others. This phenomenon is called interference of light. If path difference p equal to n lambda or phase difference phi equal to 2n pi, the two waves are in the same phase and so add up to the give maximum intensity. This is called constructive interference. If path difference p is n lambda or phase difference phi is 2 n pi, then the two waves are in the same phase and they add up to give the maximum intensity. This is called constructive interference. If p equal to 2n minus 1 under whole bracket lambda upon 2 or phi equal to 2n minus 1 pi, the two superposing waves are out of phase. The two superposing waves are out of phase. The resulting amplitude is equal to the difference between their individual amplitudes and hence the intensity is minimum. This is called the destructive interference. Now, Young's double slit experiment. Young's double slit experiment. In Young's double slit experiment, the two identical narrow slits S1 and S2, the two identical narrow slits S1 and S2 are placed symmetrically with respect to narrow slit S illuminated with monochromatic light. The interference pattern is obtained on an observation screen placed at large distance d from S1 and S2. The distance between S1 and S2 is small d. The position of nth bright fringe from the center of screen is xn equal to n d lambda upon d, small d. The position of nth dark fringe from the center of screen is xn dash equal to 2n minus 1 d lambda upon 2d. Fringe width is the separation. Fringe width is the separation between two successive bright or dark fringes and is given by beta equal to d lambda upon small d. Now, the resultant amplitude and intensity of interference. Resultant amplitude and intensity of interference. If A1 and A2 are the amplitudes, if A1 and A2 are the amplitudes and I1 and I2 are the intensities of two coherent waves having phase difference phi, then their resulting amplitude and intensity at point of superposition are given by A equal to under root A1 square plus A2 square plus 2 A1 A2 cos phi and I equal to I1 plus I2 plus 2 into under root I1 I2 cos phi. If amplitude of each wave is A0, if amplitude of each wave is A0 and intensity I0, then I equal to 2k A0 square under the bracket 1 plus cos phi and it will be equal to 2I0 under the bracket 1 plus cos phi and it will be equal to 4I0 cos square phi upon 2. The term 2 under root I1 I2 cos phi is called the interference term. Interference term. Number 1. When cos phi remains constant. When cos phi remains constant, the two sources are coherent. The intensity will be maximum at points for which cos phi equal to plus 1 and minimum at the points for which cos phi equal to minus 1. Number 2 is when cos phi varies continuously with time so that its average value is 0. When cos phi varies continuously with time so that its average value is 0 over the time of interval of measurement, the resultant and intensity of all points will be I1 plus I2. No interference fringes are observed. No interference fringes are observed. This source is called incoherent. Ratio of intensity at maxima and minima of an interference pattern. Ratio of intensity at maxima and minima of an interference pattern. If A1 and A2 are the amplitudes of two interfering waves, then the ratio between the intensities at maxima and minima will be I maximum upon I minimum equal to A1 plus A2 under the bracket whole square under the bracket a1 minus a2 whole square equal to r1 r plus 1 upon r minus 1 whole square. If r equal to a1 upon a2 equal to under root i1 upon i2 is the amplitude ratio of the two waves. If W1 and W2 are the widths of the two slits, if W1 and W2 are the widths of the two slits, then W1 upon W2 equal to I1 upon I2 equal to A1 square upon A2 square. Now the coherent sources. What are coherent sources? Two sources of light which continuously emit light waves of same frequency with a zero or constant phase difference. Two sources of light which continuously emit light waves of same frequency with a zero or constant phase difference between them are called coherent sources. Two independent sources of light cannot be a coherent sources. Two independent sources of light cannot be a coherent sources. They have to be derived from the same pattern source. Now, the conditions for sustained interference. What are the conditions for sustained interference? The two sources should continuously emit waves of same frequency or wavelength. Number two, the two sources of light should be coherent. Number three, the amplitudes of the interfering waves should be equal. Number four, the two sources should be narrow. Number five, the interfering waves must travel nearly along the same direction. Number six, the sources should be monochromatic. Number seven, the interfering waves should be in the same state of polarization. Number eight, the distance between the two coherent sources should be small. The distance between the two coherent sources should be small, and the distance between the two sources and the screen should be large. Now the displacement of interference fringes. Interference fringes. When a thin transparent sheet of thickness T, when a thin transparent sheet of thickness T and refractive index mu is inserted in the path of one interference beam, the extra path difference is introduced by delta P equal to length T in transparent sheet minus length T in the air. Length T in the transparent sheet minus length T in the air. Delta P equal to mu T minus T under the bracket mu minus 1 into T. Net path difference for any point on the screen equal to xd upon d minus mu minus 1 into T. For the central point of screen, xd upon d minus mu minus 1 into T equal to 0, and that will be equal to x equal to d upon d under the bracket mu minus 1 into T. Thus the shift in the central bright fringe and hence shift of any other fringe is delta x equal to d upon d under the bracket mu minus 1 into T. It will be equal to beta upon lambda under the bracket mu minus 1 into T. Interference in thin films. Interference in thin films. A soap film or thin film. A soap film or thin film of oil spread over water. A soap film or thin film of oil spread over water shows beautiful colors when seen in the reflected light. This is due to the interference between the light waves reflected by the upper and lower surfaces of thin films. The ray reflected from the upper denser surface of the thin film suffers a phase change of pi or path difference of lambda upon 2. Reflected system. Now, reflected system. The path difference between the two consecutive rays reflected from the upper and lower surfaces of the thin films of refractive index mu and thickness T is given by P equal to 2 mu t cos r minus lambda upon 2. For maximum intensity, 2 mu t cos r equal to under the bracket 2n plus 1 lambda upon 2. And for minimum intensity, 2 mu t cos r equal to n lambda. Transmitted system. Transmitted system. For maximum intensity, 2 mu t cos r equal to n lambda. And for minimum intensity, 2 mu t cos r equal to under the bracket 2n plus 1 lambda upon 2, where n equal to 0, 1, 2, dash, dash, dash. Now the diffraction of light. What is diffraction of light? The phenomenon of bending of light around the corners of small obstacles or apertures and their consequent spreading into the regions of geometrical shadow is called diffraction of light. I am repeating the statement once again. The phenomenon of bending of light around the corners of small obstacles or apertures and their consequent spreading into the regions of geometrical shadow is called diffraction of light. A plane wave of wavelength lambda on passing through a narrow slit of width A suffers diffraction, producing a central fringe theta equal to 0, flanked on both the sides of minima and maxima. The intensity of secondary maxima decreases with the increase in distance from the center. For nth minimum, a sin theta n equal to n lambda, where n equal to 1, 2, 3. For nth secondary maximum, a sin theta n equal to under the bracket 2n plus 1 lambda upon 2, where n equal to 1, 2, 3. Angular position of nth minimum, theta n equal to n lambda upon a. Distance of nth minimum from central of the screen, xn equal to n d lambda upon a. Angular position of the secondary maximum, theta n dash equal to 2n plus 1 under the bracket lambda upon 2a. Distance of nth secondary maximum from the center of the screen, xn dash equal to under the bracket 2n plus 1 d lambda upon 2a. Width of a secondary maximum, beta equal to d lambda upon a. Width of central maximum, beta 0 equal to 2 beta, and that will be equal to 2 lambda d upon a. Angular spread of central maxima on either side of the center of the screen, theta equal to plus minus lambda upon a. Total angular spread of the screen. Total angular spread of the central maximum is 2 theta equal to 2 lambda upon a. For diffraction to be more pronounced, the size of the slit should be comparable to the wavelength of light used. Now, Fresnel's distance. What is Fresnel's distance? It is a distance at which the diffraction spread of a beam becomes equal to the size of aperture. It is the distance at which the diffraction spread of a beam becomes equal to the size of aperture. If A is the width of aperture, then df equal to a square upon lambda. Ray optics is valid for the distance d is less than df, meaning that the distance from the source to screen should be less than the Fresnel's distance df. Now the diffraction grating. What is diffraction grating? It is an arrangement. It is an arrangement of a very large number of very narrow, equidistant and parallel slits. It is an arrangement of a very large number of narrow, equidistant and parallel slits. The diffraction pattern has the central principal maximum on minimum intensity. The diffraction pattern has the central principal maximum of minimum intensity and a number of high order intensity maxima whose intensity decreases with the increase of n, the order of the spectrum. The direction of nth principal maxima is given by under the bracket a plus b sin theta n equal to n lambda, where n equal to 0, 1, 2. This equation is known as grating law. Here a plus b is called the grating element, where a is the width of each slit and b is the width of opaque space between the two consecutive slits. Now, resolving power of a microscope. What is the resolving power of a microscope? The resolving power of a microscope is defined as the reciprocal of the smallest distance d between 2 point objects at which they can be just resolved when seen in the microscope. Resolving power of a microscope is equal to 1 upon d, and it will be equal to 2 mu sin theta upon lambda, where theta is half the angle of cone of light from each point object, and mu is the refractive index of the medium between the two objects and the objective. The factor mu sin theta is called the numerical aperture. Now, resolving power of a telescope. Firstly, I was telling about resolving power of my microscope. Now I am telling about the resolving power of a telescope. The resolving power of a telescope is defined as the reciprocal of the smallest angular separation d theta between two distant objects whose images can be just resolved by it. Resolving power of a telescope equal to 1 upon d theta and equal to d upon 1.22 lambda. Here d is the diameter of the telescope and lambda is the wavelength of the light used. Now the polarization of wave. What is the polarization of wave? A transverse wave in which vibrations are present in all possible directions. A transverse wave in which vibrations are present in all possible directions in a plane perpendicular to the direction of propagation is said to be unpolarized. If the vibrations of a wave are present in just one direction in a plane perpendicular to the direction of propagation, the wave is said to be polarized or plane polarized. The phenomenon of restricting the oscillations of a wave to just one direction in transverse plane is called the polarization. Now the law of Malus. What is the law of Malus? This law states that when a beam of completely plane polarized light This law states that when a beam of completely plane polarized light is passed through an analyzer, the intensity I of the transmitted light varies directly as the square of the angle theta between the transmission directions of polarizer and analyzer, I equal to I0 cos square theta. Here, I0 is the maximum intensity of the transmitted light. Now the plane of polarization. Plane of polarization. The plane of passing through the direction of the wave propagation. The plane of passing through the direction of wave propagation and the perpendicular to the plane of vibration is called the plane of polarization. Now the plane of vibration. I am telling about plane of vibration. The plane containing the direction of vibration and the direction of wave propagation is called the plane of vibration. Brewster angle. What is Brewster angle? The angle of incidence at which a beam of unpolarized light falling on a transparent surface is reflected as a beam of completely plane polarized light is called the polarizing or Brewster angle. Now the Brewster law. What is Brewster law? This law states that the tangent of the polarizing angle of incidence of a transparent medium is equal to its refractive index, mu equal to tan theta b. Doppler effect. What is Doppler effect? It is the phenomenon of the apparent change in the frequency of light due to the relative motion between the source and observer. It is the phenomenon of apparent change in the frequency of light due to the relative motion between the source and observer. The apparent frequency nu dash is given by nu dash equal to nu 1 under the bracket 1 plus minus nu upon c. When source moves towards the observer, the velocity v is taken positive, and when it moves away from the observer, it is taken negative. Doppler shift. What is Doppler shift? The apparent change in the frequency of light due to the Doppler effect is called the Doppler shift. Delta V equal to plus minus V upon C into V, and delta lambda equal to plus minus V upon C into lambda. I hope you have liked my video. If you liked my video, please like and subscribe my channel. Thank you.